Hey all, welcome to the first of what will be lots and lots of Math 116 videos. This section is 0.2, the real numbers, and it starts off with some Pemdas. So Pemdas goes parentheses, exponents, multiplication, division, addition, subtraction. So at the parentheses, we always want to start in the innermost, which are going to look like that, and called parentheses, and then they go out to brackets, and then the last ones out are braces. Exponents are pretty much exponents. Multiplication, division, we work left to right. Same thing for addition and subtraction. So looking at this first one, we have -5 squared. And a lot of times people will punch that into a calculator and just go -5 and then square it, and it tells them it's -25. But that's because they don't put the parentheses in. So the parentheses means this is -5 times -5. So when you see those parentheses like that, you have two negative signs, so it's going to be a positive. And then 11 times 2 is going to be 22, so the negative and negative makes positive 25, and 22 for 47. This next one uses a symbol that you may or may not be familiar with, which is absolute values. And absolute values just kind of look like two straight lines. And if you do the absolute value of a positive number, say the absolute value of 3, it's 3. If you do the absolute value of a negative number, it's still 3. And what an absolute value is if you have a number line, let's say that's 0, and we'll go 1, 2, 3, 1, 2, 3. The absolute value of 3 means it can be 3 units this way or 3 units this way. So the 3 is like the distance, but it doesn't care about direction. So that's kind of what absolute value does. So for this, we're going to go 8 minus, and then inside that absolute value is a 5 minus 7. So that's going to make a -2 inside its own absolute values. And then negative of exponents, so we got 36, and 4 squared is going to be 16. And then the absolute value of 2 is going to be 2. But there's that minus sign in front of it, so we're subtracting a positive 2. And down here we got absolute value 36 minus 16 would be 20. So up top, 6. And the absolute value of 20 is positive 20, but because of the negative sign in front, it's like it's being multiplied by a -1. So that would be -20. And then we can drop the absolute value, so 6 is still 6. And then we can cancel out a 2 on both. So 2 would go into 6 3 times. So what I'm doing is 3 times 2, and I'm going 10 times 2, and I'm knocking out the 2's. So then 2 goes into that 10 times. And usually we like to write the negative on the top. Okay, these next ones will be ones that have you guys try in class. So we got inside the parentheses first, so it's going to make an 8 squared over 4. We have to do the exponent before we can divide, so we can't make that a 2. So 8 squared would be 64, and then divided by 4. And then 4 goes into 64 16 times. And so you can see if we did make that a 2, 2 squared would be 4, it'd come out 1, so we don't get the same answer. So that's why we have kind of agreed upon order of operations. For this next one, we got an exponent, so I'll make that 25. And then there's all this multiplication coming up. And so I've cleaned up the exponent so I can do the multiply if I want now also. The way I think of it, it's 3 negatives, and if you have an odd number of negatives, there'll be a minus. If you have an even number, then minus and minus will make plus. So I just count up the number of signs, and that tells me what the number is going to be. 2 times 5 would be 10, times 4 would make 40. And then downstairs we got 14, so there's an exponent, so that beats the division. So we'll make that 36 divided by 9. 25 minus 40 is going to be -15. And now I have a choice between subtraction and division, so we do division first. So 14, and then minus 36 divided by 9 will be 4. And then -15 over 10. And then reducing the fraction. So again, I'm thinking of this as 3 times 5. I'm thinking of this as 2 times 5. I'm canceling the 5's. I got -3 halves. Okay, so this next page has like way too much information to hold on to without some context. So I'm just going to kind of hop back and refer to this as I do problems. Okay, so number 5 is write an inequality that describes the interval and graph. So this is what's called interval notation, and so that's right here in the middle of the sheet. With interval notation, we always write it from small to large, and we're going from endpoint to endpoint. If we have parentheses like this, then it's going to be not equals. It's going to be like an open dot on the graph, and the inequality wouldn't have an equal sign on it. And then this little symbol means infinity, and so this says we're going from -3 to positive infinity. So if we graph that, we just come over here to -3, and we're using an open dot because this tells me that we're not including the -3, and then it's going to go that way. And so that would be our graph, and then our inequality notation would be x is bigger than everything up to but not including that 3. So the x is larger. Notice this and this are going the same way. -3. Number 6, write an inequality in interval notation that describes graph, same thing. So for this, oh no, this time we have to do interval notation also. Okay, so let's do that one first because I actually think it's easier. So if I have a solid dot, our graph is right here with solid on one side, open on one end. So that's going to go from 0, would be my left endpoint, up through but not including the 5. And since that's open, we use a parenthesis. So that was the interval notation. And then for inequality, we would say the x is going to stay between the 0 and the 5. And so any value in here is going to be less than 5, but greater than 0. So the x is bigger than the 0, but less than the 5. Or you can think of 0 is less than the x values is less than 5 is probably actually a better way of saying it. Okay, for these next two examples, we're using union and intersection. So the word or this symbol that looks like a U kind of, those two things go together. So or goes with this. And that's going to be a union. What it means is we take everything from one set, everything from another set, and toss them together. So if there's answer anywhere, it counts. And then so and is going to go with intersection, and that symbol looks like that. And what an intersection is just like on a street, if two streets are intersecting, the intersection is the place where they overlap. And so any place the sets overlap, that would be our answer there. So let me show you what that looks like with some context. Number 7, graph the subset of the real numbers that is represented by the following. So this one we got negative infinity up to 5, and then that's that intersection, -2 to infinity. And so if we think of negative infinity up to 5, that means we'd have one endpoint right here. And then this one's going, and then this would go this way, right? Because we're going to negative infinity. This one would be -2 to infinity. So we'd have an endpoint here, and then this would be going that way. So we got one of these going this way forever, one of these going this way forever, and this little area right in between them, that is where they overlap. So that would be our intersection. So that's what that graph would look like. Number 8, graph the subset of the real numbers as represented by the following. So x is greater than 5, so here would be 5, and then greater than, so that's going this way. Or x is greater than 3. So that would be 3 and still going this direction. And so in this case, if it was an intersection, we'd only pick this part, but this one is an or, so it goes with union. This one's an intersection, it goes with and. And so for a union, wherever we have answer would be the answer. So like if you're doing this on the computer, all you'd want to do is start at negative or at 3 and just draw a continuous line from there. These are the ones that have you guys try. So write an inequality that describes the interval of graph. So from negative infinity up to 5, So there's 5. And then my graph would be going that way. So in this case, the x is less than, right? Because the arrow is going that way. Not equal to, though, 5. This next one, write an inequality in interval notation. So let's see, interval notation, endpoints -6, and that's included, so we use a bracket. And then right hand is 2 with parentheses because of the open dot. And then for inequality notation, this is where we're going. The -6 is going to be less than or equal to x, which is going to be less than 2. Number 11, -infinity to 5, and we're intersecting that with 1 to infinity. So -infinity up to 5, that would be right here, and going this way. And then we're intersecting, so we only want to put graph where the two overlap. So 1 to infinity, so there's 1, and that would be going this way. Graph the subset, real numbers, so -infinity to 7. So 7 would be right here, and then this would be going this way. And then from 1 to 4. So that'd be 1, and then to 4. So this one's a union, so it's going to be every place we have graph. So what we would put in the computer is just this thing going to infinity. 13, so x greater than 5. So x greater than 5 would be going that way, and x less than 0, that would be going that way. And this one's an and, so it's our intersection. So these don't intersect at all. So in terms of the computer, we want to just leave the graph blank, so we don't graph anything, and then it's a does not exist, or it could be empty set. Number 14, so this one is just kind of about learning to read these problems and kind of making friends with your calculator. So the expenditures E for government public health activities in billions of dollars can be approximated by this equation. And then this is where T is the number of years past 2000. So this may be the first time you've seen this. What they're doing is they're setting a more convenient T. So T equals 0 is going to be 2000. And then, 2001 T would be 1. So it just makes the easier numbers to work with than having to plug in big, giant 2000 numbers. So what T value represents the year 2007 is the first question. So that's what we were just talking about here. 2007 is 7 years after this. So this would be T equals 7. The actual expenditures for 2007 were that. What does the formula give as an approximation? Round your answer to the nearest billion. So nearest billion, we got to come back here and go, so this formula is going to spit out, if it spits out a 1, it's a 1 billion. So this is actually telling us to round to the ones place. So then what we'll do is we'll just put all this, we'll put the T in. And then we just put it in a calculator. So it may be that you've never figured out how to square things on your calculator, so I'm going to show the steps. If you know that already, skip past this part. So we're going to go 5.03 and then times 7. And on this calculator, it's this little raise to button. Yours could be an x to the y, but the little caret's a pretty normal one. Squared, and then plus 100 times 7 plus 1380. And so there's the calculator answer. And so we're rounding to the nearest billions, so that's going to be where the decimal is. So E would be 2326, and then it was 0.47, so this would stay as 6, and that is billions. C, estimate the revenue for 2014. So that's the exact same thing I just did here. So I'll just say it comes out to 3766. billion. Okay, so this problem doesn't have anything harder than like addition, subtraction, and doing a couple of percents, and it's all about careful reading. So we have a sales clerk's take-home pay is found by subtracting all taxes, retirement contributions from gross pay, which consists of salary plus commission. Given the following information, complete A through C. So her salary is $300. Her commission is $750 and change. So that's going to be all of her income. And then retirement is 5% of gross pay. So that stuff together is our gross pay. And then taxes, this is where it gets a little funky. So state and local, they're 1% of gross pay. Federal withholding is 25% of gross pay, but less retirement. And then these two are gross pay. So we have this kind of gross pay less retirement piece versus all these other things that are gross pay. So question 1 is find the gross pay. Okay, so that's the 300 plus the 750, and that makes $1,050.41. So B, find the amount of the federal withholding. Round your answer to the nearest cent. Okay, so federal withholding, that's going to be right here. It's 25% of gross pay less retirement. So first we got to figure out the retirement was 5% of gross pay. So her gross pay is the 1050 number. And then we need to knock off 5% of this because of retirement. So that's what they're going to withhold from. So with retirement, that you pay the federal withholding after you retire is the idea. So here we're going to go 1050, 41, and then we're going to multiply that times 0.05. And that's because we're taking 5% of this, and then we throw that in a calculator, and that comes out to 97.89. So we're taking all the money she made, and then 5% of that, we're taking that away, and then this is what's left, is $997.89. So this is the amount that the federal withholding will get taken of, because again, it's 25% of gross pay, but less retirement. So now we can go 25% of this. And we toss that in a calculator, and we get 249.47. Okay, part C is find the take-home pay. So going back here, if I add up all the other taxes, the state, local, and then Social Security and Medicare, and put all that together, it's that'd be 13.65. So our other taxes, we said 13.65%. And then all of these were gross pay, which was this $1,050 number from the last page. So if I go 1,050.41 and then times this as a decimal, then that gets me 143.38. So that's all those other taxes. And then we have our federal withholding already. And we just need to go back and grab retirement. And so if we do 5% of her gross goes to retirement. And so that number was 52.52. So we got a gross pay, and that's the 1050.41, and then minus retirement, so that was the 52.52. And then minus federal, and that was our answer to part B. So 249.47, And then the other taxes, which we found up there, which was 143.38. So that was how much money she made, and then retirement came off. The other taxes came out of the gross, and then the federal came out of the reduced gross income after retirement. And so if we take this and minus those three, she gets $605.04.